Here's another example where prior to calculators, it would be really difficult to do a problem like this. With a calculator, it's really easy to just type in the cosine of 3, and it's going to give you a decimal accurate to 8 or 9 decimal places. Let's see how accurate we can get without a calculator, and then we'll check how accurate our answer actually is. First thing I want to say here is that we're going to approximate the value of cosine of 3 in radians and not in degrees. So if we were in degrees, we'd actually be really close to 0 at the beginning of the period. Since we're doing it in radians, we're pretty close to what? Pi. So we're going to approximate it using pi as our anchor point here. And we'll see how accurate we are here with it. So we're going to approximate close to pi. And I want to use the formula again here, because if you know the formula, all you have to do is just plug in the stuff that you know. The linearization at x is going to equal, well, we're going to say a equals pi, right? We're going to be close to pi here. So it's going to be close to the value of the function. What function are we going to be looking at? What does f of x equal? Okay, so we're looking at the value of cosine of x close to pi. What does the linearization formula say? What's the first thing? F of a. We said a is pi, so what's the cosine of pi?
-1.
Right?
Yeah.
Yes?
How do we know what A is?
We just picked a value that we picked an a value that we know the cosine of, as close to 3 as we could. So the only value close to 3 that I know the value of cosine is at pi. We could maybe try to check like, and we'd have to kind of do a little bit of math here, but maybe 3 pi over 4 would be close to it also. That might give us something more accurate, and we could do a little bit of math with the identities that we know with trig to figure out what 3 pi over 4 is. Actually, we wouldn't really need to do that. It would just be a 45, 45, 90 triangle. That would maybe be a little more accurate depending on how close it is to pi. Okay, so we're going to try pi because it's fairly close to 3. So we're going to start at -1, and then we're going to add on the derivative at a. What's the derivative of cosine? Negative sine. So the derivative is going to be negative sine of x. And what is the sine at pi? 0 times x minus pi. Right? You guys agree with that?
Yeah.
Well, this is an easy one to figure out. What's 0 times anything? 0. So what this is saying is the tangent line, and I'm going to write this here, no matter what x is, the tangent line is going to have a value of -1. So in the region close to pi, cosine is going to have values close to -1. So let's see how accurate we are. If we plug in 3 here, so the linearization at 3 is going to be -1, which means that cosine of 3 is approximately equal to -1. Let's see how close we are. Use your calculator to check. Be sure you're in radian mode. If you get an answer close to 1, that means you're in degree mode. Did you get... .9898, you said? Okay. How close are we? I mean, we're about 1/10 away, right? So that's pretty close. Depending on what we're doing with it, that's probably close enough. So as long as we're pretty close to pi, That's going to be pretty close. If we wanted to find the cosine of 3.1, that would be even closer to -1, right? Now we would use the same approximation here, and since the tangent line doesn't have any slope, all of our approximations around pi are just going to be -1. Okay. Again, as Devin suggested, we could use a second derivative to figure out about how close of an answer that's going to be also, and we'll get to that later.